This is Unit 9, Kinetics and Equilibrium. Lesson 1, Collision Theory and Factors that Affect Reaction Rate. How do reactions occur? The objectives of this lesson: I can determine the effect of effective collisions on reaction rate, and I can determine how factors affect reaction rate according to collision theory. Do now. So kinetics is defined as the study of the rate or speed at which reactions occur. A reaction is defined as the breaking and reforming of bonds to make entirely new compounds as products. Effective collisions are how we describe how reactions occur. In order for a reaction to occur, the reacting particles must collide effectively with the following conditions. 1, they must have the proper amount of energy, and 2, they must have the proper orientation or angle. That is, the particles must hit each other the right way. So, for example, if I had hydrogen gas and iodide together, this reaction would not occur because they are not aligned properly. They're not in the correct orientation. This reaction will not occur because there's not enough energy for them to create new products. However, this final reaction would occur because not only are they aligned in the correct way, there's enough energy here for the reaction to occur. So stop and think. Now, there are 6 factors that affect the rate of reaction by changing the number of effective collisions that take place between particles. In essence, the more effective collisions, the faster the reaction. Our first factor is the type of reactant. Ionic substances react faster because they easily break into ions when you dissolve them. For example, when I put silver nitrate solid in water, it breaks apart, it disassociates into its ionic components, silver ion and nitrate ion. Covalent substances react slower because it requires more energy or time to break the bonds. So, for example, H2 is strongly bonded together, I2 is strongly bonded together, so it's more difficult for these covalent substances to react because it requires more energy for them to break and reform. So, stop and think. The second factor is concentration. If I increase the concentration, I'm going to increase the reaction rate or the speed because more particles increases their chance of having an effective collision. So low concentration means I'm not hitting each other as much. However, more together, higher concentration means more collisions will occur. The third factor is temperature. If I increase the temperature, I'm going to increase the reaction rate. This increases the number of effective collisions because, in a couple of ways, the reactants have more energy when colliding because they're going faster. So you could think which would have a higher rate or a speed of collision, a 5 mile per hour fender bender or a 50 mile per hour high speed crash. You could just think about your knowledge of cars and how they move. What would have a more effective collision, so to speak? Stop and think. The fourth factor is pressure. If I increase pressure, I can increase the reaction rate. However, this affects gases only. And this is due to an increase in concentration. So if I have a low pressure of gases, the particles are spread far apart. They have less chance of hitting each other. However, if I increase the pressure, now my gas particles are closer together and thus have a higher chance of having an effective collision. The fifth factor is surface area. If I increase surface area, I'm going to increase the reaction rate. And this is due to more exposed particles that can react more effectively. So if I take my circle, or my sphere, so to speak, I won't have as much surface area because there's not that many places for reactants to come in contact. However, a cube has more surface area, but if I divide that cube into smaller and smaller pieces, those exposed surfaces will increase my reaction. So stop and think. If you can't see any of the words, look in your notes. The sixth factor are catalysts. A catalyst is defined as a substance that increases the reaction rate without being consumed in the reaction. And it does so by speeding up the reaction, by reducing the activation energy, and providing an alternative chemical pathway. So we talked about these before, and on a potential energy diagram, we'll talk more about how on a potential energy diagram it would look. So quick review of these factors that affect reactions. Ionic solutions have faster reactions than molecular compounds. The increase in temperature will increase the rate. Increase in concentration will increase the rate. Increase in surface area will increase the rate. Increase the pressure, I'll increase the rate. And conversely, if I decrease the pressure, I'll decrease the rate. And catalysts just speed up reactions. So check your understanding of these factors. And now you can determine the effect of effective collisions on reaction rate, and you can determine how different factors affect the reaction rate according to collision theory.